Hi, everyone. It's a pleasure to be here. My name is Ami, and I'm the head of process at Atlantium Technologies. And today I will be describing the positive effect of using Atlantium UV system as a pre-treatment for RO. So in a nutshell, Atlantium established 2003, been around for 20 years now. Actually started as a laser company. The idea was to use laser for disinfection. Eventually, in 2008, the company shifted its course and became a UV manufacturer. Today, we have a unique IP UV system called the HOD, that stands for Hydro-Optic Device. Our core business, aquaculture, food and beverage, industrial, municipal, all over. Today, we have more than 3,500 installations worldwide. I'll dive into the technical part. And I skipped the RO intro. I assume that most or all of you are well familiar with our technologies. Just wanted to share two thoughts we have on fouling. First of all, biofouling is related to 80% of membrane failures. This was well shown in regards to, let's say, 30 to 50% as a direct influence of biofouling. And then biofouling will also induce scaling because of the low velocity, high viscosity layer formed on the membrane surface. Biofouling will also induce membrane oxidation because of the biofilm has very low local pH, much like we see in our tooth cavities. And of course, biofouling will also trigger a rapid cleaning for the membrane. In regards to chemicals, needless to say about the hazards and about the dealing, but we often see also that the chemicals that are being used to prevent biofouling actually enhance biofouling. And I'll just give two short examples. One is chlorine. Chlorine will eventually increase the available organic material, the food source for the bacteria, more food for the bacteria. The SBS, the sodium bisulfite, will also result in an anaerobic environment, which is, as I said before here, which is way harder to remove than aerobic bacteria, and it will also serve as a food source for anaerobic bacteria. I mean, the sulfate itself. So the story with Atlantium and RO protection begins not with disinfection, but with dechlorination. By the way, this is Atlantium Systems. Nice to meet. A 6-inch system here on the photo. So Atlantium typically says systems for disinfection, but over the last decade or so, we also produce larger, high kilowatt UV systems for dechlorination, which is, as you know, chemical process. And this is used as an alternative for sodium bisulfite or for carbon dechlorination in various of industries. So we had many pre-RO dechlorination installation, and the feedback that we got here from client was very positive. Not only did the UV was able to remove the chlorine as it should, but also the client experienced very good influence in terms of increasing the frequency between one CIP to another, or increasing the frequency between filters replacement. Now, we didn't know at the time if this positive effect was caused by removing the sodium bisulfite, as I said before, which is a food source for the bacteria. Also, carbon filter is also induce biogrowth very rapidly, or was this a side effect, a disinfection side effect from using the HOD UV as a prior to the RO? So then we conducted a very fundamental research together with some universities and sites to see how low, how short the UV can go. I'm saying short because in Atlantium systems, it's modular. So when you have a low kilowatt system, it's shorter. So how low the UV can go and still have an attractive return on investment, and also remove the EPS from the membrane and influence the operational parameters. So after we gain some knowledge and move to field installations, and this is a good example here that you can see of an installation in a client that gave us a closer look at the data. So this is a 100,000 cubic meter per day seawater RO facility. The UV is installed right here. This is the system. I don't know if you see my cursor, but this is the system installed right upstream to the cartridge filter. So they had 12 RO skids. Each skid was each RO train was treating 750 cubic meter per hour. The plant experienced many frequent CIP and frequent cartridge replacements. So the process in the plant was seawater entering, going to a clarifier, later on after filters, UF membrane, cartridge filter, RO, and then a post-treatment to be used as drinking water. And the UV, as I said, was installed right upstream to the cartridge filter. It was a 12-month study, and here I'll show some of the results. First of all, the parameters evaluated CIP frequency, the filter's replacement frequency, DP between, of course, brine side to the feed side, permeate flow, and the salt passage. Some results. So this is the x-axis is the 1 year time, and the y-axis is DP across the membrane. This is an indicator for us for biofouling. Each drop in the curve is, of course, a CIP. So 13 CIPs in the 6 months before UV installation, 8 CIPs in the 6 months after UV installation on the same train, of course. And the interesting here is the post-CIP DP that dropped after a several CIP cycle, dropped by 20%. Now, this is also, we see it in other installations, this phenomena as well. And we say that in simple words, you can say that the biofilm was more fluffy, was easier to remove using the same CIP procedure. That's the yearly count of CIP events between the protected UV train to the parallel unprotected trains to the left and to the right of the UV. And it's interesting to see that the unprotected RO trains kept similar numbers as the protected train prior to the period with UV. So that's 30% less CIP cycles. Same trend can be seen even more clearly in the cartridge filter replacement. So it was 60% less cartridge filter replacement. Now, in this case, it didn't matter to the client so much in terms of cost, but it allowed us to demonstrate the good capabilities of this technology in terms of the downstream equipment protection. And lastly, and this was also a surprise to us, we've witnessed that the accumulative permeate flow, the production of this train per year to compare with other trains was higher in 8%. Now, this was both resulted from less downtime, less CIP, less filter replacement. This is less downtime, but also we witnessed that the normalized permeate flow went up by a few percentage. And immediately we suspected that something was wrong with the membrane integrity. But then we looked at the salt rejection and it remained unchanged from after the installation of UV. Okay, to summarize it, 40% decrease in CIP frequency, 60% less in cartridge filters replacement, 20% decrease in the post-CIP DP, the initial DP after CIP. Cost savings were calculated by the client. So less biofouling, less chemicals, longer working durations. I think I managed the time right, Walid. If you have questions, please free to ask.